If you have any query from the past class regarding the complexity or anything else, just let me know. All right. So I hope all of you can see my screen. If not, let me know. Cool. So we discussed about the idea and the mathematical basis of the complexity theory. We discussed just a quick recapitulation of what happened yesterday. We talked about, you know, sorry, yeah. So we talked about order big O and the order of growth function, where the n is the problem size, right? And we also discussed about what is a leading term, what is a leading term, like n square plus 2n plus 6. So this is the leading term that will always dominate the complexity, right? We also talked about this particular notion of big O, which is if you have, sorry, yeah. So the notion was that um, this expression always holds to be true, which is k times the order of growth function is always going to dominate um, the overall number of the instructions, right? Which we write as this, uh, and that is going to be true for where n is greater than equal to m, and both m and k are positive integers. That's the definition we discussed yesterday. So today, yeah, we'll start by looking at what are the different complexity classes and how, and this is it, right? We will not extend it further, but explore yourself. There are many very good books which you should look at, like Corman, sorry, CORMEN, I guess, if I'm not wrong, and or Sahani. These are all very good books for studying algorithms. Corman is the best among all this. Just let me close my WhatsApp. But it is very detailed. It could be slightly intimidating for you. Okay. All right. So the same problem can be solved using different kinds of complexities, right? I mean, not necessarily the same problem is always solved with the same complexity. The algorithm complexities will vary, and accordingly, they will take more or less time. So the fastest are like log n and constant. So if you have a constant amount of operation that you are doing, then that is often written as order of 1, right? Or order of c is also fine, where c is a constant. Then comes log of n, right? It is barely there. Yeah, sorry. Is there any
Sir,
question?
yes, sir. Could you please remove this bar which you are getting meet.google.com, because I don't see what is plotted on the x-axis.
Okay. So
Or maybe if you can move screen a little bit. Yeah, I can see now its elements. Yeah.
yeah, so elements means that you have this is the problem size, in other words, right? That means the size of your array, and this is the number of operations that you are performing, right? And you can see that there are different classes. The constant time will just be flat, and then log n, then uh, then n log n, then n square, and so on and so forth, right? So what is very interesting here is this particular case, or this particular case, it takes a lot of time, right? So n square, n cube, all these things are manageable. But when you have the n on the top, right, let's say 2 raised to n, if this is the complexity, then this algorithm is terribly slow. I don't know how many of you are aware of the recent discovery of the recent breakthrough by Google company. It's called DeepMind. They discovered, not discovered, they actually implemented a machine learning, deep learning based solution to the problem of protein folding, you know, which is understood to be a very challenging problem. So it takes exponential amount of time to solve a protein structure. That means given the amino acid sequence, if you want to predict the structure of the protein in 3D, right, that problem is indefinitely complex. Even if we use all the computers of the entire world full time, you cannot solve the structures of the proteins. Okay, so they developed an approximation algorithm through deep learning, which very accurately approximates the structure of the protein in very short time. Okay, so that's a new world. It's an entirely different world. So wherever you have complexity, there are classes such as NP hard, okay, which are problems which typically take a lot of time, where that will typically arise when you don't have a solution which is less than an accurate solution, which is less than, let's say, x to the power n. So when n goes here on the top, that's the biggest problem. So there are many algorithms to solve these NP hard problems, but they gives you approximation, right? So there are many optimization methods. Optimization, even deep learning, machine learning, all of them are optimization in some or the other sense. You need optimization where you cannot get the accurate answers. Okay. So my request is that whenever you come across any simple algorithm, you look at it from a complexity point of view, because this is where the computer science elements will crop up. Okay. Otherwise, it is mostly like running programs and writing scripts, inefficient scripts. You will never acknowledge the importance of writing, fast scripts. But unfortunately, as you saw in case of binary search, this is something that we'll teach today, and you will see that how much time it saves as compared to the linear search, and you will see how the complexity gets reduced substantially. Okay. So what I do is next.
Sir,
Yeah, sorry. Go ahead.
just a question. You said that look at the algorithm from the complexity point of view.
Yeah.
What exactly do you mean? I mean, are you referring to the to the power n factor, or what exactly you
No,
mean?
so if you see that linear search, okay. So let's say linear search is where you have multiple elements, right? And then let's say you are searching 6, okay. So you'll have to scan this entire array, okay, and that takes you order of n time. We saw it yesterday, and the exact number of operations performed on an average was coming around 3n plus 1 by 4. And we said that this is equivalent to writing order of n, because the rest of the things don't really matter. Okay. So even if I give the even if I give you a sorted array like 1 2 5 8 18, sorry, 18, right, to find out a certain number, the amount of work that you will be doing is equivalent to order of n, right? But in binary search, for example, the same task can be performed if the array is sorted in a much lesser time. So instead of order of n, you will spend order of log n, right? So now you can choose to use binary search over a linear search, okay, because that is fast. Similarly, in industry, as I was giving some example, that if you want to perform, let's say, k nearest neighbor search, that means you have a database. There are, let's say, 10 million customer records. Then you are searching for a particular customer, that who are the ones that are closest to your this query, in terms of whatever it, in terms of Euclidean distance, and in terms of cosine distance, some distance, right? You want to find out the customer records which are close enough to the one that you are querying with, right? So in this case, you will see that you need to spend a lot of time. You need to check one by one that what is the which one is this. So for example, for all 10 million records, you will have to check one by one and compute the distance, and the distance computation itself has a cost. So for all records, for I in 1 to, let's say, 10 million, you will keep moving, right? And you will compute the distance with each of these records. And this is very complicated. This takes a lot of time. Even if you consider that as a, you know I won't call it nearest neighbor. Let's say you want to find out who are the top 10 guys who are close to this query, right? Now that will take a lot of time. You cannot scan all these 10 million items in a second. Okay. So there are methods which are over there called hashing. Okay. Which allows you to actually assign some kind of a zip code, I would say, to your data, because your data could be a big vector, but it can be made concise by some random projections. Okay, so for example, if you have this kind of data, and let's say they are clustered together, okay, and I mean, this could be high dimension as well, right? I'm not drawing all the dimensions. This could be 1,000 dimensional data. So typically, let's say a telecom company will store so much of information in their records in the database about one particular customer, right? So those data are voluminous. Now, what is done alternatively is, you can keep yourself on mute, please, kindly. Yeah. So what you can do alternatively is, you can actually draw hyperplanes, random hyperplanes, like H1, like H2, like H3, and so on. You can draw random hyperplanes, and you can you can compute dot products. So these hyperplanes are basically some equations, right? So you can simply see that whether they are on the left side of the hyperplane or the right side of the hyperplane. So I'm just giving one example how we can do it very, very fast, right? So let's say these are my hyperplane equations. I'm sorry, I'm sort of diverging a bit, but I think this is an interesting discussion. So let's say H1, right? So you have, let's say, points P1, P2, P3, P4, P5, etc., etc. So for every hyperplane, sorry, not this. For every data point, you will actually compute data point P1, P2. You will compute whether it is on the left side of the hyperplane or the right side of the hyperplane. Right. So you will compute, you will give 0 or 1 on the basis of that. Okay. And that becomes a binary code that encodes each of the data points. All right. Each of the data point is encoded by some random projection led binary strings. Now the interesting part is that if they are close by, so while drawing these hyperplanes, I did not think about where they are drawn. Truly speaking, while drawing, I just drew them randomly. But even by my random action, what you can see here is that P1, P2, and P3 are always on the same side of the hyperplanes. Like for this hyperplane, for H2, sorry, For H2, they're on the left side. For H1, they're on the left side. For H3, they're on the left side. And you see, apart from this guy, who is slightly at a confusing state, the rest of the points are and this guy to some extent, the rest of the points are together. They are on the same sides of the hyperplanes. So for those hyperplanes, they will have exactly same value. For this guy and this guy, there will be one hyperplane difference. So a very prolific Indian data scientist was the professor of Stanford. His name is Rajiv Motwani. Who is no more, by the way. He died in his Kashmir residence swimming pool. He was a Stanford full professor and the mentor of the Google founders, Sergey and Larry. So he discovered this method of, assigning a bit code to a very high dimensional vector, so that, if you get a new query, let's say I get a new customer query and I get it here, or let's say I get it here. Now, if I compute the binary bit code for this guy, then it is going to be likely very close in terms of having distance. If you just bitwise measure the difference, like, if I have one data point P1, 0, 1, 1, 0, another data point, this 1, 1, 1, 0, then only here I have a difference, and that is called Hamming distance. So the Hamming distance between these two strings is 1. So you see, when you have a database query, right? If you have a database query, you can immediately use these hyperplane equations to see that whether the data point is the left hand side or the right hand side, and accordingly you can come up with a bit string. Let's say this is the hypothetical bit string, right? And then you can compare with all the bit strings that you have got from your data, right? And accordingly you can say that, okay, whichever has the same or the nearby bit strings are the close neighbors. This method is such a important breakthrough in the world of big data algorithms, right? I cannot even explain. Okay, so this is a big data algorithm, right, that solves the same problem of finding the nearest neighbors much faster, much efficiently. But yes, one caveat is that this is approximate. Okay, so it turns out that all the things happen at a n log n kind of a speed. So the complexity analysis of this is kind of involved, work. I don't want to do that here. It will not be meaningful. But you can read this up. It is called, the method is known as locality sensitive hashing. Okay, and there are other alternative methods which does it a lot more efficiently, like these days sketching and all that. Okay, so you see, the same problem can be solved very differently. Instead of taking, let's say, n time, if I take log n time, I don't know, I think it's log n time, or if I instead of n cube, k nearest neighbor, if I take n log n time, it's much better. So if you start doing the complexity analysis, you'll realize that this method is much faster in practice. When you implement, you will also see the output comes very quickly. Okay.
Okay, I think I got a fair understanding. So to summarize, for my intuitive understanding, earlier I think we were discussing, I mean, we touched on the binary search. So it's like, a sophisticated form of, binary, n-ary, or whatever you call it. I mean, similar approach to solve a problem in a hyperplane.
Right. So you are actually assigning a zip code to a data, and the data could be very big. You are randomly assigning zip code in a manner so that the same similar data points are likely to be assigned the same or nearly same bit code. Okay, so
Hmm.
that's a clever way. In fact, I don't know whether you realized that in the Fibonacci you used dictionary yesterday. Did you?
Yeah.
Yeah. So did you realize that how much time you are saving in doing so? So I would request all of you to check that if you implement Fibonacci in the traditional way, and if you implement Fibonacci by using dictionary to avoid, unnecessary computing, how much time you save. It is going to be a very interesting exercise for you. So please do that. So you use the traditional Fibonacci, traditional, where somebody gives you a Fibonacci search f6, you go f5 and so on, and then you sort of walk the entire tree, right? And in the other case, what you can do, see, this tree is growing exponentially, right? Every time it is doubling up. So the order of growth will be like this. Now, what you did essentially is you did every computation only once and then you stored it, right? For example, F4, once done, you don't do it again here. So you store the F4. So then the same thing, just by a small trick, you bring down to log n, right? Because you are doing exactly once. You are doing every computation exactly once and no more when you use the dictionary. So can you imagine how much of time you are saving in that, instead of some exponential like, form? You are essentially saving a lot of time had you computed all these things together.
Sir, just wanted to know one thing. So, since you are discussing algorithms, as and you also told that it would require much applications in data science, and you also prescribed the book Codeman. So, actually, Codeman was something which, like, I used to learn while giving Gate. So it's like a Bible sort of thing. It's I can sleep on it or something like that. So it's very difficult to study that, as you mentioned. So, can you suggest a way or a course or
Yeah,
something?
yeah, yeah. So I think I'm just forgetting Kleinberg. So there is a book by Kleinberg. Kleinberg. A good question. And Turdas, I guess. I don't know what is the exact spelling of it. So please note down, Kleinberg and Turdas is something that is much easy to understand. Easiest among all these books if you are a beginner. And not even a beginner, I think it's a good enough for even a serious algorithmist to learn the crux of the algorithm analysis. Okay?
Yeah, thanks a lot, sir. Thanks a lot.
Okay, all right. Cool. So now let us do a small sort of warm up exercise that, matrix multiplication. Okay. So what I request all of you to do is to solve the matrix multiplication problem. So here is how matrices are multiplied. Um, so you have, let's say this is m times n dimensional matrix. So where m is 2 and n is 3, and then this is an n times p dimensional matrix where n is 3 and p is 2. Okay, so their inner dimensions are compatible. This is exactly the same. So the way matrix multiplication works is the row elements are multiplied with the column elements of the next matrix, and then they are added up. Okay, so the final matrix, so if you multiply, I think all of you should know matrix multiplication. If you multiply m times n matrix, let's say matrix A, with uh, with what's wrong? Sorry. If you have a matrix m n and you want to multiply with um, n p, then the result that you get is m p, right? And it is important that the inner dimensions are compatible. They are the same. Okay. So this is the final matrix. So your rows are multiplied, like 1 is multiplied with 10, plus 2 is multiplied with 20, 3 is multiplied. And that resultant value is the value of this matrix, the first row, first column of the matrix. And then you multiply this with this column, then this with this column, and so on and so forth. The row times column is the way to go. And here you get the final answer. Now, what I want you guys to do in the next half an hour, to very quickly, not half an hour, you have exactly 20 minutes. It's a damn simple thing to do. So, Tanishi, please set up an assignment, and I request all of you to write a code for matrix multiplication using for loops. Don't use any API. Use a for loop to multiply. Consider those matrices in a list. This should be one list, this should be another list, and then you just multiply using for loops. And you got to tell me that what is the, if your matrices, if your input matrices are m times n and n times p, right? Then your final matrix is m times p, right? So you have three variables here: m, n, and p. Okay. Now you will have to tell me that what is the final complexity of the algorithm. You'll have to write down that on a page. Okay. So please write the code, and please write the complexity analysis of the code, not more than 2-3 lines. Okay. I don't want a real theoretical analysis. All right. So please get started. You will be given 20 minutes for this assignment. And for ones who are more comfortable with, I mean, for ones for whom this is very simple, please try out taking the user input, of m, n, and p. Okay, ask user for what is m, what is n, what is p, and take the matrices as entry, input. For ones who are not so pro in Python programming, can simply consider two static matrices of different dimensions, like 2 by 3 and 3 by 5, and then produce the result. Both will get the full grades. So
So we
type,
have to do it on paper or on our
no,
system.
you'll have to code it up, and the final code you will have to put it on a paper. And put it on a paper means you can just put it in the a screenshot of that. Okay, this is such a simple thing. I don't think Tanishi will have to run your code to see that whether it is right or wrong. And the second thing is you write a couple of lines about the complexity in the same page and take a PDF and submit. Tanishi, will you please
Yes, sir.
create an assignment? Thank you.
Yes, yes. Uh, Excuse me, sir.
Yeah, please tell me.
So what should I keep the deadline for this assignment means 12
Just
o'clock
20
or
minutes. 20 minutes. I think 11:55 is good enough.
okay, sir. Okay, sir. Who's Alam Raj over here?
Sorry, is there a question?
Uh, Sir, I was just asking who is Alam Raj. Actually, he has submitted the assignment, but I just found that same code on GFG. So I
Yeah, there
just
is a
wanted to.
plagiarism case, and plagiarism is
Yes,
punishable.
yes, sir. So that's why I was just asking who is Alam Raj, so that I can discuss with him. Alam Raj, are you here? Please unmute yourself. Uh, Almaj, if you are having any doubt, anything, if you are facing any issue, you can just discuss. Don't copy. Try it again. Try it yourself. Otherwise, you can discuss. There is no hard and fast rule that you have to submit it in the deadline. But try it yourself. Yeah.
The deadline is 11:55, isn't it?
Deeptarshi, can you be loud?
The deadline is 11:55, isn't it?
Yes, yes, yes.
Okay,
But if you're facing any problem, you can discuss it over here.
okay, ma'am. Thank you.
Okay.
Ma'am, can you explain a little bit about the multiplication part? Like if I printed the first matrix and second matrix, but the
Yes.
multiplication part is.
Okay. Can you share your screen or means
I'm
multiplication part with this? Yeah.
actually, ma'am, I'm doing it on laptop and I'm attending this with a phone. So
Okay. Okay. Wait a minute. I just. Yes, Sunidhi.
Ma'am, I wanted to ask how we will assign the values in the resultant matrix, like in C++.
Okay, wait. I'm just showing it. Yes, who was that? Ankita? I think so. Ankita was
yes, ma'am.
facing.
Yes, ma'am.
Yeah.
Mm-hmm.
Okay, okay. For example, you are having 1, 2, and 3, and this is list 1, and this is list
I'm
2.
not.
Yeah.
Your screen is not visible.
My screen is not visible. Wait a minute. Now it's visible.
Yes, ma'am. But
Yeah, you can just means Tanishi presenting just over
yes,
there.
ma'am.
You
Yes,
can
ma'am.
just pin that. Okay. Yeah. Now you can see that I am having L1 array. Wait a minute. Wait. Yes. Over here you can see that I'm having L1 array in which the elements are 1, 2, 3, and L2 is having 5 and 6. So I wanted to multiply this both the list. So what will I do? First of all, I will iterate in L1 one by one. Means if I print this, for example, if I print here, it will print like 1, then 2, then 3. It will iterate like that. Then I have to multiply each element of L1 with each element with of L2, and I'm making a list like L3 is the list. So what I'm doing, I'm
Ma'am, your
just
screen is
hello.
again lost.
Okay, okay, wait a
Screen,
minute.
ma'am. Screen is not visible again.
Okay, wait. Now it's visible. You can just pin me.
Guys, you can
Like,
take till 12.
yes, sir.
Tanishi, please extend the time.
Okay, sir. Okay, sir. Uh, Ankita, you can right now see my
Yes,
screen.
ma'am.
Yeah. So
Yes,
you are
ma'am. Yes, ma'am.
having the two lists L1 and L2. L1 is containing 1, 2, and 3 values, and L2 is having 5 and 6 elements. I have made an empty list L3, and over here I'm just calculating. I'm just multiplying each element of L1 with L2. So in this we can see if I print this, for example, if I print this, it's iterating each element of L1, and if I print this statement, means if I just comment this out, if I print this statement, it will give 1, then 2, then 3. This part I think so is clear to everyone.
Yes, ma'am. Yes,
Yeah.
ma'am.
Now I'm just means I'm putting the nested loop inside this, means I'm nesting the loops. So I'm taking another variable j which will iterate over the L2 list, and what I'm doing, I'm just making a variable like mul, and over there I will calculate I into j, and I will directly append this value in the L3. And when I print this, I will get each element, means like what will be the result? What should be the result in the L3? What should come in L3? Can someone say that? If I multiply each element of L1 with each element of L2, what should be the result?
1 into 2 matrix it will be.
Yes, but what should be the result? Is there any volunteer, anyone wants to say? I'm simply just right now I'm simply एक एलिमेंट मैंने L1 का लिया, एक एलिमेंट L2 का लिया, दोनों को मल्टीप्लाई करके मैंने L3 में डाल दिया. देन अगेन मैंने उसका L1 का
30 36.
yes 30 36 हाउ इसमें तो
By
ये तो मैं
multiplying
सिंपल
the
मल्टीप्लाई कर रही हूँ, यहाँ पे मैट्रिक्स मल्टीप्लिकेशन नहीं कर रही हूँ मैं. व्हाट आई एम डूइंग, मैंने 1 को लिया, यहाँ पे जैसे फर्स्ट आइटरेशन में I equals to 1. Yes.
The size of the L2 must be of 3, I think.
Vivek, can
So
you
the
be a
first,
little, yeah? Can you be a little loud, Vivek?
Then the size of the L2 should be of 3, I think, for the
No,
for
I'm
the
not doing the matrix multiplication. Matrix
Okay.
multiplication different है, पर मैं सिंपल बता रही हूँ कि दो अगर मेरे पास लिस्ट होंगी तो उसमें कैसे मल्टीप्लाई करते हैं हर एक एलिमेंट को.
तो मैम ये पहले
Matrix
L2
yeah.
का 5 लेगा और फिर उसके बाद वो L1 के सारे एलिमेंट से मल्टीप्लाई करेगा और
पहले हाँ yeah.
फिर it will take 6 and then it will multiply with every element of L1.
Yes, you are saying right, but L1 and L2 को मतलब तुमने वो कर दिया है, vice versa. Over here, सबसे पहले ये जैसे कि यहाँ पे है, क्या यहाँ पे पहले I की वैल्यू 1 होगी, देन वो जितने भी एलिमेंट्स है L2 के उसके साथ मल्टीप्लाई करेगा. लाइक यहाँ पे 1 into 6 हो जाएगा, देन फिर मतलब सॉरी 1 into 5 होगा, देन फिर L3 में 5 स्टोर हो जाएगा, देन फिर उसके बाद 1 into 6 होगा, देन 6 स्टोर हो जाएगा L3 में, फिर उसके बाद I equals to 2 होगा, ये सेकेंड एलिमेंट पे जाएगा, देन अगेन इट विल मल्टीप्लाई 2 with 5, then 2 with 6, then it will contain what 10 and 12, then फिर उसके बाद 3 के पास I equals to 3 होगा, नेक्स्ट एलिमेंट पे जाएगा
15 and 18.
15 and 18. So this will be your output. L3 में ये पूरा आएगा. Yeah. तो आई थिंक सो मल्टीप्लीकेशन क्लियर हो गया होगा. मैट्रिक्स मल्टीप्लीकेशन में डिफरेंट हो जाता है. मैट्रिक्स मल्टीप्लीकेशन में तुम लोग को उसमें मल्टीप्लाई भी करना है, ऐड भी करना है, तो वो लॉजिक सोचो कि कैसे मैथ्स अप्लाई करते हैं तो कोडिंग में कैसे होगा. आई थिंक सो दो चीजें क्लियर हो गई होंगी कि कैसे हमें मल्टीप्लाई करके लिस्ट के अंदर स्टोर करवाना है, सेकेंडली कैसे मल्टीप्लाई करना है. Ankita and one more girl
Ma'am,
was having, yeah.
ma'am, then we need to have another empty list also for adding.
No, simply you can add
Like,
using a variable only.
okay, ma'am, I'll try.
Yeah, try. Just think maths में कैसे solve करते थे वैसे ही यहाँ पे simply solve होगा. Means just see that you will need a loop extra or not, or need a new variable, means more variables to calculate or not. And this is 1D list, but in matrix multiplication you must be having a 2D list. I hope the doubt is clear. Anyone who is getting problem in multiplication or how to add an element in list?
Yes, Tanisha, I have some confusion here.
Yes.
Can I just share my screen?
Yeah, sure.
So you can see my screen. Tanishi?
Yes, I'm so sorry. I was muted and I was saying yes. Yes, I can see your screen.
Okay.
Yeah.
So I have like taken the dimensions from the user. For now, it's like fixed, and they have entered the values in a row-wise sequence. Say like for matrix one, this one will be the value, and for matrix two, this one. Then
Okay.
according to their the size of the matrix, I have inputted the value in the list.
But how you
Hmm.
are taking it as a 2D array?
Yes.
Yeah.
So now I have to multiply these three with the first element of each list in this element. Correct.
Okay.
So
So
I'm here.
first of all, maths का rule तो पता होगा ना, like n into m then m into p, मतलब फर्स्ट लिस्ट अगर m into n है तो सेकेंड लिस्ट जिसके साथ मल्टीप्लाई कर रहे हो उसका m into समथिंग होना चाहिए, मतलब दोनों के रो एंड कॉलम के जो कोऑर्डिनेट मतलब वो
हाँ, ये सेम
वैल्यूज
होने
होती है वो
चाहिए।
सेम होने चाहिए. हाँ.
हाँ,
या
तो वो मैंने सेम रखी है।
तो यू कैन टेक इट इन वन वेरिएबल ओनली ना, व्हाई ओ यू आर टेकिंग इट द सेम
हाँ,
वैल्यूज.
वो बस मैं अभी अपने क्लियरेंस के लिए रखा हूँ, बाद
अच्छा.
में फिर
ओके
सेम
ओके
कर दूंगा।
ओके.
हाँ, तो वो तो किया मैंने। अब मेरे को इसका लूप नहीं समझ आ रहा कि इस तीनों को मैं इनके फर्स्ट फर्स्ट एलिमेंट से कैसे लिखूं।
Guys, we'll
अच्छा.
have to start with the class. Tanishi, I think you can
यस.
explain it during the lab hours as well.
ओके
But I think whatever
ओके.
you have submitted, submitted. I really appreciate people who have tried to do it themselves, even though they have had a hard time to solve it. I really appreciate. Thanks. Okay, now what I'll do is I'll share my screen. We'll have to cover some more topics today. So I'm just sharing my screen. Just allow me a second. So I
Just
think
one,
it's available to all.
just one point to Tanishi. Actually, I was working on it, but I'm getting some error, so I'm not submitting it. But I will work on it later on and submit it.
Yes, yes, we can talk in the rap session. Yeah.
Yeah,
Okay.
yeah. Awesome. So, simply speaking, I think what we need to do is to remember that we are the easiest way to look at it is m times n is one matrix. Another matrix is n times p. So you need to fill a matrix which is actually n m times p, right? So m rows and p columns. Okay. So you'll have to run one for loop with m, another for loop with P. So that will give you the location of each values, right? Each cell of the result matrix. Okay. So that is how you get two for loops, and then finally one more for loop that will run under this, which is for the inner dimension, which is n, and that will be used to multiply the column with the row. Okay, the dot product that you do, and then finally you will have the answer. So this is how you get an order of m times n times p. And if this is a square matrix, if it is a square matrix, then it will be m cube. Okay. And here is the algorithm, how you achieve that. I think it's pretty straightforward, so I'll not spend time on this now. What I'll do is I'll go through some other topics that I decided to teach today. So let me just open my slides. So there is a very fascinating world of fractals. Okay. So recursion is something that occurs in nature very frequently. And we'll see that some of the intuitions, just give me 1 second. Okay, now, so I'll not go through the basics of introduction. This is a very nice, interesting thing that you'll see if you type recursion in Google. It will keep showing you, did you mean recursion? So that's really funny. So although you type key in the right spelling of the recursion, you will still see the recursion. They're suggesting, do you mean recursion? Okay, so that's a way to show how the recursion works. So one interesting observation that you will always have is like the structure of the tree, right? So these are the These are the Euclidean geometry, like the circle, the square, the line. These come very frequently in Euclidean geometry. But there are certain real life objects that don't follow the Euclidean geometry at all. In fact, in real life objects, you will see. Sorry, I think I'll have to stop the WhatsApp again. Just a second. So the circles and squares and lines are perfect objects. They appear in the real life. I'm not saying they don't appear, but I think most of the time, the things that we observe, which are naturally created, nature-made stuff, are not really following the Euclidean geometric objects, right? So they follow some very interesting structures, like you see in the trees, you see in the lightning bolt, you see in the mountain, and those can be explained using the concept of fractals. Okay, so that's a mathematical instrument that is used to model a lot of interesting phenomena in even real world, human world, right? For example, the stock prices follow the patterns of a mountain, which is not perfect. It is not triangular. Okay, it has a lot of curves, it has a lot of dips and ups, and that can be rather explained using a concept called fractal. So for example, your blood vessels, your coastline of a sea, a tree structure, shape of cauliflower, all these are kind of repetitive structures. And just look at this structure of the alveoli within lung, right? So you see that, you have this branching even that is happening repetitively. Okay, so every tiny part, if you focus on just this circle, right, then if you magnify it, you'll see that it looks like the overall thing again. It is self-repeating structure, and it gives rise to massive objects with massive complexity just based on some simple rules. We'll see some examples right here. So you understand what is fractal. These are repetitive structures that you observe in objects. So here is Apple stock. So how the values of the things move. The stock value is moving across. So x-axis is the time and the y-axis is the value of the stock. And as you can see that this is, I mean, if you just focus on one particular part, right, which is a very small chunk of the price movements on a particular day or a particular minute, it actually mirrors the overall structural properties of the entire stock, movement along a longitudinal movement of the stock prices, right? So if you see it, it again looks something similar to this. Not exactly same, but it looks somewhat similar to what you see here. That's very interesting, isn't it? So here is a interesting mathematical structure that you can see that first there is a line. You divide the line into three pieces, right? And then you delete the middle one. Okay. So if you keep doing this, then it gives rise to a structure that you can see on the right hand side. So this is called Keter set, and Keter set is also found in European architecture, Egyptian architectures, like you can see on the screen. You have already studied the recursion, how it works, right? Because recursive calls of the function. So this is the recursive function for the computation of the factorial. So when you call for a particular factorial, you want to compute the value of a factorial, like the factorial of 4, right? It calls factorial of 4 times factorial of 3. It calls the factorial of 3 times factorial of 2, etc., etc. Then in the end, when it hits the base case has to be on the top. Whenever you hit the base case, you just return 1, and then on you get the answer, right? So it goes up now. So like it becomes 1. When you hit factorial 1, it gets evaluated as 1 because this is the base case. And then this entire thing, factorial of 2 times 1 gets evaluated. You get 2 and so on and so forth. So this you have already seen, and I guess this kind of pictorial representation of how the recursion happens is very important for you guys to understand how things work. So it is kind of a referral system. You keep referring until you hit the base case, and then once you hit the base case, you get the value, and then you go back and you sort of evaluate all these pending calls. Like when you call 4 times factorial 3, the factorial 3 call is pending because you really don't have the answer to factorial 3, and then so on and so forth. But in the end, when you have the answer for the factorial 1, you can go on computing all the pending calls essentially. So that's kind of a cool thing about how programs and and the algorithms work in a recursion. So these are some of the salient features of the recursion. Like the recursive algorithm must have a base case. So a recursive algorithm must change its state and move towards the base case, right? Because here you can see that every time you make a recursive call, the parameters, the arguments are changing. You started with 4, then you go to 3, you go to 2, and so on and so forth, right? So it is reducing towards, it is going towards the base case, because that is essential for you to evaluate, to compute the value of any of these function calls. Of course, a recursive algorithm must call itself multiple times. Okay. So here is another example with a geometric object, which is circle. And what this function is doing is it is actually reducing the size of the circle, and it is creating inner circles with reduced radius. So draw circle is a function that draws the circle, right? And you are just applying the coordinates, right? The coordinates remain the same. The x and y are never being changed here. But what is getting changed here is the radius. Every time the radius is reduced by 25%, right? So whatever is your radius to start with, you reduce it by 25% and then draw the circle, a concentric inner circle, and keep doing that. So just with this simple, idea, you can actually create a beautiful, concentric circle structure. So you can make it even more complicated. So can you guess that what kind of a program is written? What kind of recursive program is written in this? What can somebody try? Okay, so what is happening, since we are running short of time? So this is the solution. Just let me know if you understand what is happening here. So here you are making two calls, right? One on the left hand side, one on the right hand side. You are dividing the radius by 2. Okay, both for the right hand side and the left hand side call. Your x and y are not changing, just the radius. Sorry, your x is changing. Here the coordinates are also changing. So you are no more drawing the concentric circles. What you see here is that the x and y are changing here. And the way it is changing is you sort of add radius plus, radius divided by 2 to the x, right? So you are changing the coordinates of the circles depending on the coordinate of the initial x, the x coordinate value, right? And the radius is also decreasing. The radius is decreasing by 2 every time. So you should go on until you hit the base case, right? The base case is whenever it gets equal or less than 2, you don't repeat this. So it will eventually terminate. So you can do the same thing for the 4 circles. So here is the code for it. And again, the base case, as you can see, is greater than 8. So that means, anything equal or less than 8 will terminate, right? So you can draw this beautiful structure. And eventually, what is interesting here is you never imagined that this operation will lead to some kind of a square shape. So here you see that there's a square shape that is emerging here, right? And the square shape is not obvious how it is happening, right? From this existing code, it's quite surprising to get that shape, but it happens. So one interesting property of the of fractals is that the final shapes are quite unpredictable. like the simple branching events, how does it give rise to a tree structure, is something that is quite surprising. So it is not easy to predict the final structure by looking at the recursion in case of fractals. So fractals are kind of very good geometric objects to understand and study recursions. So here is one more example. You have three lines here. So you delete the middle, you divide it into three pieces, and you sort of create a triangle here of the same size, and you keep doing that. You keep doing that for each of these lines, right? You keep doing the same thing again and again. So it gives rise to this beautiful structure here. So here is the example. Here is the algorithm. Start with the line, divide into three equal parts, draw an equilateral triangle using the middle segment as its base. Erase the base of the equilateral triangle. So you draw an equilateral triangle. An equilateral triangle is one where all the sides of the triangle are the same. You delete the base, and you are remained with the structure, and you repeat this 2 to 4 as many times as you want with some base case, and the base case could be the length of the sides. So it is known as a monster curve, right? And it's the Koch curve, which I just showed you, and other fractal patterns are often called mathematical monsters. And you know why? Because, sorry, because you can fit a very, just imagine that you keep doing this. You keep doing these operations. Then what will happen is the total length of all these pieces here will increase infinitely. Okay, but that will fit into a small piece of paper. You can keep going on and on and on. You'll realize that the overall lengths of all the sides are increasing infinitely. However, they are always fitted into a small piece of paper. So it's kind of a, I would say, fallacy. You know, you sort of, it's studied a lot in mathematics. Fractal is a very well studied mathematical geometric object. Okay, so I'll directly switch over to binary search. So let us see how binary search happens through one example, and also we'll study the algorithm and the complexity of it. Okay, the idea is that how can we reduce the linear search time for an array. So I have an array, and I want to search, and that array is sorted. So my assumption is that my array is sorted, and I want to search for a particular number. Now it turns out that it can be achieved very rapidly, okay, using binary search. And binary search is very similar to bisection method that we have studied earlier. So this is the algorithm. I'll show an example and how the example, a numerical example, that how it rolls over the array and how this particular element is found. Or if it is not there, then it declares that it is not present in the array. So let us look at this left-hand side algorithm pseudocode. Okay, so binary search, what it is doing, it is taking an array. Just pay a lot of attention here for ones who don't know how the binary search works. Just a second. Okay, so what is happening here is that I have an array, which is sorted array. I have the low and the high. We'll see what they are doing. Okay, and I have an element that I'm trying to search in the array. If I find good, otherwise I'll have to report that the array is not present. Okay. So what I'm doing next, so this is the array as an example. So my low is 1. The initially we set low as 1, right? Because the array is 1, 2, 3, 4, 5, 6, 7, 8, and the high is 8, right? The first and the last cells. And then the number we are trying to search is 6. Okay. And now we'll see how it happens. So number one, so you enter into the program, you check if low is equal to high, greater than high. Is low greater than high? No, right? So you don't get into this return false. You don't get in there. Low is not high. Okay. Then you get into mid equal to low plus high by 2. Okay. So low by high plus 2 is 1 plus 8 by 2, which is 4. You compute that. So this is the place where you are trying to split it into halves. Then what you check is whether your x is equal to the middle element that you are now pointing to. Okay, so your mid is pointing to this location, and then you want to see that whether your element is there at the mid location. So you are indexing a at mid, that returns you 4, and you are looking for 6. So 6 is not equal to 4, and therefore it is returned as false. I mean, it doesn't get into this condition at all. It skips the condition, in other words. Then you look at if x is less than, then you look at if x is less than the mid, right? If it is less than the mid, okay, so then what I do is, so there are three possibilities, right? One, it is equal, which we looked at in the previous statement. The next is if it is less, and the next is it is more. So you basically want to decide that whether you will have to look at the left hand side of the array or the right hand side of the array. So is 6 less than a of 4? No, right? 6 is more than a of 4. So you'll not enter into this part. So you'll skip that. Then you are stuck in the next one because it is saying x is more than a mid. Yes, 6 is more than 4. Because at the fourth place of the array you have 4. 6 is more than 4, and therefore you enter into this particular condition. Now what happens is you again call the binary search, but here you do something interesting. You change the low and the high. You don't change high, but you change the low. Okay, so your low is mid plus 1. You want to start looking from the right side of the mid, because mid is not equal to, because see, you have seen that x is less than a mid, right?
I can't hear anything. Is it same for all?
Yes. Yeah, yeah.
Yes, yes.
I think so. There must be a net issue. I just called the server.
Hello.
Wait a second. I'm just calling.
Hello, Tanishi.
हाँ Jubi.
Uh, Yesterday I have sent an email to you, but you haven't replied to me. Can you just?
I didn't
Uh,
receive any
yes,
email.
I have given a mail to you. Okay, no
Okay,
problem.
okay.
After this class,
We can discuss in the lab session. Wait a second. I'll
yes, yes,
just
yes. Thank you.
try to call Dibakar. So yeah.
Madam, can you hear me, please? Can you hear me, madam?
Oh, guys, just sorry. I think the connection was disconnected. I'm back again, Tanishi. Guys, can you hear me now? I think some technical
Yes,
Yes,
glitch.
sir.
yes, yes,
I
yes,
Yes,
was
sir.
yes.
Yes, sir.
Yes, sir.
Yeah, now you are audible. Yeah.
sorry. I was talking to nobody actually. So did I start explaining you how the binary search work, the algorithm? Where did you lose me?
You were half through.
Half through. Okay, halfway through. Great. No problem. I'll do that again. Thanks, Tanishi, for calling me.
Yes, sir.
Yeah.
So screen is means you have to share the
Yeah, I'm
screen.
sharing my screen again.
Yes, sir.
Where is the okay, guys, so sorry for that, but anyway, that's a part of the life these days. So this is your binary search program. So I think I started talking about how it works. So binary search takes the following arguments very quickly. A is the array. So it has a static set of elements which are all sorted. 1, 2, 3, 4, 5, 7, 9, 11. So you see the A, which is an array, is completely sorted. And then you have the low and high. Initially, the low and high are, assigned to 1 and 8, which is the first element and the last element. Then you have a number that you are searching. Okay. A number that you are searching, which is 6. Now see what happens here. You first check if low is equal to high. Of course not. Then you don't get into this condition. You skip that. You define a midpoint. So even if you remember, in case of binary bisection search, you were trying to split every time you were splitting you would split the array or the possibilities into two halves. So here also you are doing exactly the same. You are dividing the array into roughly two halves, and for that you need to define the middle point. And the middle point is low plus high by 2, which turns out to be roughly 4. You are taking the floor of it, right? So 1 plus 8 is 9. 9 divided by 2 is 4.5. You take the floor of it, right? So that is the 4. So you take the floor. So fourth location. So mid is pointing towards the mid location, not the value, right? So then you check that if x is equal to a of mid location of a, whatever value is there. In this case, incidentally, you have the same value as the location, so it is 4. So of course it is not equal to what is there in the mid. And then you skip. You see that whether the number that you are searching, which is 6, is less than the item at the fourth location. In this case, it is not true. Therefore, this condition is also skipped out, but it is caught in the next condition, where 6 is greater than 4. And therefore, you enter into this condition. You again call the binary search program. Okay. And this time, what you are doing is you are looking at the right side of it, right? Because clearly, so just carefully look at what are you trying to say, because 6 is greater than what is there at the middle location. So there is no point in searching in the left side. There is no point in searching at the site which is at the middle. But there is a lot of value in searching at the right hand side. If at all there is this number, it will be at the right hand side. Therefore, logically speaking, you'll have to start from looking at here, the 5th location to the 8th location. How do you get the fifth location? That is mid plus 1. How do you get the eighth location? That is already 8, right? So you just change the low. So this is the parameter argument which is setting the low. And the low now becomes mid plus 1. The high remains the same. And you iteratively call the binary search program with a changed parameter 5 and 8 here. Fair enough? Okay. Now what happens is, now you have 5 and 8. You repeat the same thing. Is low greater than high? Well, 5 is not greater than high. You don't get into this condition at all. You also compute the mid. The mid is now 6. Okay. Then you look at the number at the sixth location. If it is equal to the number you were searching, that is not true. You were searching for 6. And the number that resides at the sixth location is 7, which is not same as what you are looking for, and therefore it does not satisfy this condition, and therefore it skips it out. It gets into the next condition. It is now searching that whether x is less than the element at mid. The element at mid is 7. X is not less than 7, or it is less than 7, right? It is less than 7. So the outcome is yes. Therefore, you enter into this condition. And this condition is again searching into the array. But this time, you are searching on the left or the right. You are searching on the right, because x is less than the element at the mid. So there is not much value in looking at this location or the location right of it. You'll have to look at the left location. And incidentally, there is only one value in here. So the protocol of setting in the, so your low remains the same, right? The low is 5, it remains 5. But your high will now be 6 minus 1, the mid location minus 1, that is 5. So incidentally, your low and high will both be 5 in this case. Okay. Then you enter the binary search program again. You check low is greater than high. Well, no. You compute mid, it becomes 5. You check if 5 is a solution that you are looking for. No. Then none of these things will get. So if x less than 5, 6 less than 5 is false. 6 more than 5 is also false. Right? So nothing happens. You no more call the binary search function. Your program essentially terminates. And in this case, you'll have to report at the time your program terminates, right? You'll have to report that I didn't find it, right? But if the number is there, it will be caught at here. It will be caught at here. And then it will stop. Okay. So in a way, this is your base case when the program terminates. Okay. So this is how the binary search works. Now you can look at how much time this search takes, right? Very interestingly, all these recursive calls. So how many times, because you are splitting the array into halves, right? You are splitting the array into halves multiple times. How many times you can split an array into 2 equal halves, roughly equal halves? Log of n with base 2, right? So log n times this program will be called. Okay. And then all the tasks that you are doing within this program are constant amount of work. So some C1 plus C2 plus C3, some constants, right? So you are actually doing log n times constant amount of work. So the overall complexity will be order of n, order of log n, which is much less as compared to, significantly less as compared to n. Okay. So this is how the algorithm works. If you have a question, just let me know. After that, Tanishi will take over. I have requested her to give you some quick examples of the strings and the tuples and the lists today. She will take over for 20 minutes now and during the lab session. I will not. I will not give any more assignment today. I will give assignments. Of course, Tanishi will give some class assignments. Those will not be graded, but I'll set some assignment for the week, upcoming week, in a day or two. All right. Happy to answer if you have any clarifications for the binary search.
Sir, it's possible to share this presentation which you referred, and primarily like when you were explaining the algorithm or originally fractals and all those things.
Sure. I'll share the presentation with all of you.
Okay, thank you.
Cool. Then Tanishi, I think over to you. You can start sharing your screen.
Yes, sir.
Uh, I will exit the this thing, but I'll see if I can make you an administrator so that you can stop the recording as well. Okay, because
Okay,
otherwise
sir.
the recording keeps happening. It continues.
Sure.
So yeah, over to you.
Is my screen visible? Yes,
Yeah.
Chogi John. Yeah.
Yes, ma'am.
Yes, Chogi. Joji. Yeah.
Yes, already I have asked you, and you told in the.
I don't remember the question. Can you please
Yes, I
come?
have already
Yeah.
sent a message to you
Okay,
in
okay,
email.
okay.
But
Okay, we
okay,
can discuss
after the
this in
class.
the lab session. Yeah.
Okay, after the class, you just respond to me in email. That's all.
Okay, okay,
Thank
okay. Sure. Okay. Yeah. Now we are starting with the strings. You all must have used strings in different assignments. So, what are strings? Strings can be
Ma'am,
relate. Yeah.
ma'am, I also sent you an email. So if you could check it, please.
Okay. I will check it after the class. Okay.
Thank
Will it
you.
be fine? Yeah. Okay. So what are strings? Anyone wanted to define what are strings? What do you mean by the string?
It's a group of characters including spaces or maybe numbers.
Okay. So how you represent a string in Python or in any language?
Double
By
quotes.
single quote or double quote
Okay, yeah, good. Yes. So
and
strings
triple
can
quote.
what? Can you please pardon? Who said that?
Nothing.
Okay. Yeah. So strings can be a letter, special characters, spaces, digits, anything. Anything that is enclosed in double quotes or a single quote. So string can be concat means we can concate the means we can add both the strings by the plus sign, this addition sign. We can add the space or we can directly add another string with it. So, and if you want it in Python or also in Java, also in Python, there is like I want something repetitive. It means, for example, I want name 3 times. So I can directly do name into 3. That will repeat the name string 3 times, and we can add it to the like silly will contain hi space name like that, name without any space. So like we can see like how it will print. This is in print also, like if we take any input without typecasting, it will take an input in string, and in print also we give string. For example, I'm so sorry, yeah, over here you can see like my favorite number is, over here we are passing the string, then with comma we are just adding more, like x can be integer, any string or any means it's a variable, then we are again adding a string like dot, then again we are adding x equals to, this is anything written in a double quote in print, in input, or in while assigning any variable value to the variable, anything written in a double quote will comes under the string. In string we can do slicing. For example, if I show it over here, I'm having hello. So I wanted to print like s equals to 1. What's at the index 1? E is there. But if I wanted to see which I wanted to get a string which starts from E, means from one index till the end of the string. For example, I can say end of the string, or we can say till the length of the string. So I wanted E double L O to be printed. So I can directly do this slicing, and it will directly print E want alternative steps wise. For example, I want E, then L, or I can say H, L, O with a space of 1. I can directly give like this and do it 2. So H, L, O. I think so. These things you all know, or otherwise I have to explain it out. Slicing thing, do I have to explain it, or you guys are familiar with it?
I got an idea now what it is. I never read it before. But
Okay. See, I'm having a string. For example, string name is string, means it's a comment. Okay, I'm just explaining it. I'm having a string, and what slicings do? Like, I want a string which means I'm having. Wait a second. I am. I'm I'm a teaching assistant, so I want the string teaching assistant. Not I am this string I don't want. I only want this part of the string. So what I can do, I can directly count the index. Like this is 0, I is on the 0, then space is on 1, am is on 2, then E is on 3, then starts from 5. So what I can directly do, I can do 5 and then colon. And if I'm not giving any value, means at the end over here I'm not giving. So this means till the end of the string over here. Otherwise, if I give value 6 or 7 or 8 like that, then it will start from here, and the index 6, or for example it's T is on the 5 index, E is on the 6, A is on again 7, C is on 8, and H is on 9. So it will print till here, means n minus 1. जैसे हमारे लूप में होता है n minus 1 तक ही जाता है, but we write n. So यहाँ पे भी सेम ही होगा, and ये यहाँ पे if I simply print this, it will simply give this portion of this string, means substring देगा 5 से लेके 9 तक, जिसका इंडेक्स 5 होगा, then 6 होगा, then 8, means 7, then 8. 9 तक तो वो जाते ही नहीं, means 9 consider नहीं होता है, but we write 9 to means so that it can reach till 8. I think so this part is clear to everyone. अब slicing में step wise कैसे करते हैं, like इससे start समझ लो, हमें कौन से index से चाहिए, end is the means जहाँ तक चाहिए, end can be for example अगर मुझे यहाँ तक चाहिए तो end will be ith index, मतलब जो i का इंडेक्स है, जो ये वाले i का इंडेक्स है वो हमारा end होगा. अगर मुझे teach ही चाहिए तो हम उसके नेक्स्ट वाले इंडेक्स को कंसिडर करते हैं. अदरवाइज वी कैन लीव इट ब्लैंक इफ अगर हमें पूरा एंड तक चाहिए. देन फिर उसके बाद स्टेप्स होते हैं. फॉर एग्जांपल अगर स्टेप्स 1 है कि मुझे टी चाहिए, देन फिर ई चाहिए, उसका नेक्स्ट वाला इंडेक्स ही चाहिए नेक्स्ट, तो स्टेप्स देने की जरूरत नहीं. यू कैन सिंपली इग्नोर दिस पोर्शन. अदरवाइज यू वांटेड टू मींस you wanted to get a string with a gap of 1 या फिर 2, like t है, t के बाद e को skip करके a पे, फिर c को skip करके h मुझे करवाना है, then I को skip करके n. So I can give steps for this. इसके लिए मैं जब t से टी कंसिडर करने के बाद ए कंसिडर कर रही हूँ, तो द स्टेप्स जो मुझे गैप करना होगा वो 2 का होगा. देन आई विल गिव 2 ओवर हियर इंस्टेड ऑफ विदाउट गिविंग एनी स्टेप. आई विल सिंपली गिव 2 एंड डिफॉल्ट स्टेप में 1 होता है जो हमें देने की जरूरत नहीं पड़ती. तो आई थिंक सो दिस पोर्शन इज क्लियर टू एवरीवन. स्लाइसिंग वाला पोर्शन क्लियर हुआ? इफ यू आर हैविंग
Last line. Last line was what you have written in this.
this one.
Yes, yes.
That's
And
fine.
like start and like if you wrote this
Yes.
with the step size, so it should write it would take everything from start to end, like from
Yes.
the and with a step size of 2. So it should print HLO. But
Wait.
how
I
should
just explain it. I think so सबको नॉर्मल लूप का तो डेफिनेशन पता होगा फॉर आई इन टी
yes, ma'am.
इन आई इज इक्वल्स टू 0 एंड वो करके. सो आई एम सिंपली जस्ट राइटिंग इट. कमेंट वेट. या i is equals to 0, i less than length of s ले लो, string की length ले लो, and i plus plus ले लो. Yeah. तो what simply is doing कि ये करने की जगह डायरेक्टली मैं ये करवा रही हूँ. तो what it's doing, स्लाइसिंग में क्या हो रहा है कि यहाँ पे अगर मैंने कोई भी इंडेक्स नहीं दिया है, यहाँ पे तुम्हारा स्टार्ट आ जाएगा कहाँ से मुझे चाहिए, जो ये वाला स्टार्ट आ रहा है. एंड विल बी यहाँ पे जो तुम्हारा ये आएगा, यहाँ पे इक्वल टू नहीं आएगा, कंडीशन में विल नॉट बी इक्वल टू, इट विल बी एंड. तो हमारा हमेशा फॉर एग्जाम्पल अगर मुझे टीच मतलब आई वॉन्ट टीच फ्रॉम दिस स्ट्रिंग, तो यहाँ पे मुझे आई का इंडेक्स देना पड़ेगा जिससे कि वो वहीं पे एंड हो जाए, एच की स्ट्रिंग पे एंड हो जाए. इफ आई गिव इक्वल टू तो एच मतलब आई कंसिडर होगा, इफ आई डोंट गिव इक्वल टू आई कंसिडर नहीं होगा, सिर्फ ये स्ट्रिंग कंसिडर होगी. एंड आई प्लस प्लस की जगह यहाँ पे स्टेप्स का काउंट हो रहा है. फॉर एग्जाम्पल आई प्लस प्लस में क्या होता है कि एक का इंक्रीमेंट हो रहा है, तो एक के इंक्रीमेंट हमें इतना मतलब इसमें फिर डिफॉल्ट में एक इंक्रीमेंट होगा. बट इफ यू गिव लाइक स्टेप इक्वल्स टू 2, तो ये यहाँ पे क्या रोल प्ले करेगा, हमारा नॉर्मल लूप ऐसे होगा i plus equals
Oh,
to
I got
2.
it. I got it.
You got
I
it?
got it.
Yeah. I think so everyone is clear with this.
Can you
हम
run the program?
ये पूरी चीज एक ये पूरा फॉर लूप में लिखने की जगह एक ही इसमें लिख देते हैं, तो बैक एंड में वो फॉर लूप चलता है, तो वो फॉर लूप हमें लिखने की जरूरत नहीं पड़ती. Anyone was saying anything?
Can you just run that program?
This one?
Yeah.
Yeah, it's running. Yeah.
Okay.
See what it's doing. I just explain it. हमारे पास आई एम टीचिंग असिस्टेंट था, तो ओवर हियर ये स्टार्टिंग से लेके एंड तक चलेगा बिकॉज आई हैवंट गिवन एनी वैल्यू ओवर हियर. मींस स्टार्ट हमारा ये वाला था, देन फिर एंड ये वाला था, बट मैं अगर वैल्यू नहीं दूंगी तो ये स्टार्टिंग से लेके एंड तक चलेगा. अब क्या हो रहा है इसमें, ये 2 का स्किप कर रहा है, लाइक आई कंसिडर किया, देन स्पेस को स्किप किया, ए कंसिडर किया, एम को स्पेस किया, एम को स्किप किया, स्पेस को कंसिडर किया, देन फिर टी को स्किप किया, ई को कंसिडर किया. मींस ऑल्टरनेटिव वाइज चल रहा है. इफ अगर मैं यहाँ पे 3 देती तो रिजल्ट कुछ और होता, लाइक स्टार्टिंग के आई को कंसिडर किया, फिर 2 को छोड़ा, ये 2 को छोड़ा, आई स्पेस और ए को, देन एम को कंसिडर किया, देन स्पेस और टी को फिर से स्किप किया, देन ई को कंसिडर किया, ऐसे करके ये चलेगा. आई थिंक सो दिस इज क्लियर.
Yeah, it's a clear, Tanishi. Just I had curious to know. This whole question comes to my mind. If say I am a teaching assistant now,
Yes.
I want to print this string without any space.
Without any space. Oh, that you can simply do it like you can just remove the replace space with normal, like you can simply replace space with simple string. You can simply do this. Means you don't need to do the slicing portion. It's a means role of the replace function over here.
Okay, thanks.
आई होप सो यहाँ तक तो क्लियर है। स्लाइसिंग में आई थिंक सो किसी को कोई डाउट नहीं होगा। If anyone is having doubt, you can ask. List में भी, tuple में भी, if you can means list, tuple, set, उनमें भी यही same portion आता है slicing का, बिल्कुल भी change नहीं होता. So that's why I wanted to clear this thing. means स्लाइसिंग कहीं पे भी यूज करोगे, लिस्ट में यूज करना चाहोगे तो लिस्ट में तो ऐसे हो जाएगा कि मेरे पास 1 2 3 है तो 4 है एंड if I wanted to like for example मेरे पास ये S1 है, S1 equals to this, तो इसको अगर मैं ऐसे प्रिंट करवाऊंगी, फॉर एग्जाम्पल मैंने यहाँ से 1 से प्रिंट करवाया एंड आई एम मेकिंग अ गैप ऑफ 2. सो कोई गेस कर सकता है इसका आउटपुट क्या होगा? एनीवन? दिस इज द स्ट्रिंग, मीन्स दिस इज द लिस्ट. सॉरी, स्ट्रिंग में तो समझ में आ गया होगा आई थिंक तो सबको. अब हमारे पास लिस्ट है, देन यू हैव टू परफॉर्म दिस स्लाइसिंग ऑन द लिस्ट. तो आउटपुट क्या होना चाहिए?
246.
246. ओके, एनीवन एल्स?
Yeah, 246.
246.
246.
यस, अब आई थिंक सो क्लियर हो गया होगा स्लाइसिंग कैसे वर्क करती है.
Yes, ma'am.
ये स्ट्रिंग में, लिस्ट में, टपल में, in any data structure you work with, means except the dictionary. I haven't applied, you can just check it on dictionary. But ये स्लाइसिंग कम बहुत आती है एंड हर जगह इसका यूज है. मीन्स स्ट्रिंग में, टपल एंड लिस्ट, एवरीवेयर यू कैन यूज दिस. नाउ मूविंग टू द फर्दर. यस, इनपुट का जैसे मैंने कल लैब में बताया था कि इनपुट इफ अगर हम कोई टाइप कास्टिंग नहीं करेंगे तो डिफॉल्ट इनपुट हमारा स्ट्रिंग में होता है. तो आई थिंक सो ये चीज, ये पोर्शन तो सबको पता ही है.
Yes, ma'am. Yes, ma'am.
Yes, okay. And yes, 5 into text. Okay, if I am having name and if I do 5, you can see name, this string. I'm having a string name and I'm doing into 5 times. Name will be repeated. आई होप दिस इज क्लियर. ये इसका यूज कहाँ पे आता है? फॉर एग्जाम्पल हम कोई डायमंड प्रिंट करवाते हैं, मीन्स बहुत सारे देखा होगा डिफरेंट लैंग्वेजेस में भी हम लोग पैटर्न प्रिंट करवाते हैं. तो एक डायमंड का होता है या फिर समथिंग लाइक स्टार प्रिंट करवा रहे हैं. यू वांटेड टू प्रिंट दिस स्टार 5 टाइम्स और ऐसे करके. तो इसमें क्या होगा, तुम्हारी टाइम कॉम्प्लेक्सिटी रिड्यूस हो जाती है. तुम एक फॉर लूप लगाओगे एंड उस फॉर लूप में हमेशा प्रिंट करवाना पड़ेगा सेम रो में. तो इससे बेटर एक ही बार में तुमने इंटू 5 कर, मतलब इंटू 5 करके उसे डायरेक्टली प्रिंट करवा दे, तो तुम्हारा फॉर लूप रिड्यूस हो जाता है. तो आई थिंक सो ये थोड़ा क्लियर हुआ होगा जो मतलब जिसको पैटर्न से थोड़ा बहुत फेमिलियर है कि पैटर्न कैसे करते हैं, पैटर्न के क्वेश्चंस. Is that okay? मीन्स इतना ज्यादा कंफ्यूज
Yes,
होने की
ma'am.
जरूरत नहीं है. आई एम जस्ट सिंपली सेइंग कि अगर कोई मुझे स्ट्रिंग रिपीट करवानी है तो मैं सिंपली जितने नंबर ऑफ टाइम्स रिपीट करवाना चाहती हूँ, लाइक 2 टाइम्स रिपीट करवाना चाहती हूँ, तो उससे मल्टीप्लाई कर दूंगी स्ट्रिंग को. तो सिंपली वो चीज हो जाएगी. एंड नेक्स्ट दिस इज ओके. यस, स्ट्रिंग्स थिंक ऑफ एज या स्ट्रिंग्स में कंपैरिजन होता है, लाइक डिफरेंट लैंग्वेजेस में, लाइक जावा में डॉट इक्वल्स होता है एंड डिफरेंट कंपैरिजंस होते हैं. तो इसमें हम लोग करवा सकते हैं, इसमें डबल इक्वल टू होता है. यहाँ पे हम जैसे कि नेम करवा सकते हैं नॉर्मली, लाइक इट्स ट्रू. इफ आई वांटेड टू चेक कैपिटल नेम इज इक्वल टू और नॉट, false. But if I wanted to give this string, I'm having this string and I do it dot lower. This is true or not? It's true. See, I think so. ये वाली ऊपर की तो लाइंस क्लियर हो गई होंगी सबको. इसमें क्या हो रहा है that I'm having a string name and a name with having n capital, means first letter इसका capital है. तो if अगर मैं normally चेक करूंगी तो दोनों string मैच नहीं करेंगी. But if I do if I perform lower function, means मैं इसके सारे alphabets को lower कर दूं, मीन्स इसके इक्वली कर दूं, स्मॉल n स्मॉल a स्मॉल m स्मॉल e, तो इक्वल आ जाएगा। आई थिंक सो दिस पार्ट इज क्लियर कि दोनों स्ट्रिंग्स को कैसे चेक करते हैं, एंड लोअर फंक्शन का भी क्लियर हो जाएगा। जैसे कि लोअर है वैसे अपर है, मीन्स इफ आई वांटेड टू डू अपर like this, I'm having hello dot upper. आई थिंक सो लोअर फंक्शन और अपर फंक्शन कैसे वर्क करते हैं वो भी आई थिंक सो सबको क्लियर हो गया होगा। कुछ भी डाउट हो यू कैन आस्क।
Just a question I think related to this. If I I ask user to give your input as
Okay.
a name. I mean, user can type in all caps or small or
Yes.
in camel case, but I want to print it only in camel case. So taking user inputs and then converting it to camel case, irrespective of whether it was inputted in uppercase or small case.
Yes.
Is there an easy way to do that, or we have to just make entire string lower, then first
No, there is no way to do that. You have to means whatever will be the input, you can perform dot upper and dot lower on that, means according to your need, what you want. Yeah.
Okay, thanks.
Anyone else is having a doubt, means during input you can't give any condition that it should be lower or upper. You can give it like enter the name or like enter the number, you can give it, or there can be condition like means there cannot be any condition, but you can convert like integer, float or that type, but there is no condition like you can have to give only lower or upper. You can simply give input in any format. Yeah. Anyone wants to ask any question? Hello.
Thank you. I don't have any, so we will meet after an hour again for lab, right?
Yes. And in this, you can also see the function. For example, if I'm having s equals to hello, there is a length function in which you can directly print the length of the string. Like जावा में डॉट लेन होता है, array list में डॉट साइज होता है, तो यहाँ पे len function len plays a role for taking a length, means for returning a length of string or any list or any tuple or dictionary also it's work. So this len function works over here. ये len function कहाँ पे यूज आएगा, where you don't know how many elements are in the list, तो डायरेक्टली len function को लूप में लगा सकते हो, फॉर लूप में। I hope so this part is clear. Can I move forward, और किसी को कोई डाउट हो तो प्लीज पूछ लो। Now after this len function, let me see these slides. Okay.
Tanisha, can we take a break?
Okay. If you want, we can take a break. Yes. Okay, it's 1 o'clock. We can directly start from 2 to 3. Over there, I can explain.
Okay, thank you.
Okay. Thank you.
Thank you.
Thank you.